I've conducted some pretty remarkable tests here, considering the various settings of the Thetis DSP filter setting, starting out at concentrating on just the transmit filters here at 1024. I'm going to introduce a tone. You'll see here that I have the tone set at 4100 hertz. 4100 hertz. The EQ cutoff, though, is 3600. But it's illustrative of what happens with the different size filters. So just allowing for the ambiguity of the filter edges here. For example, on the flex receiver, the filter edge is at approximately 4500 hertz, 4.5 kilohertz. A transmit bandwidth is set to 4000. The EQ is cutting it off, though, at around 3600. Now let's check what we're doing here. So on the CFC cutoff, no, it's at 4000. So we'll set that at 4000, transmitter 4000, and we'll transmit a 4100 hertz tone just up and outside the transmit bandwidth. And watch these tests as I cycle through the transmit filter bandwidth starting at 1024. I'll turn some audio on here. We'll go into transmit and watch what happens. So we'll go into transmit. Now you can see that tone. That tone is being transmitted about 4100 hertz. I'm at the 1024 filter. Let me cycle through the filter sizes. Next up, 2048. You see the amplitude of that tone has decreased. Now watch what happens when I go to 4096. The filters completely cut out that tone, which is outside the passband, the transmitted passband. Very, very steep skirt. Doesn't seem to make much difference from here if I go up to 8192. You don't see the signal. 16384. The signal practically all but disappears, but you still see some painting there. So let me step back through. Watch the filter sizes as I step back down. Okay, let's go out of transmit. Now, if that wasn't dramatic enough, let me show you what happens at the other end of the filter. So we'll set the tone to 50 hertz. My transmit low cut is set to 60 hertz. 60 hertz for the low cut. The test tone will be set at 50 hertz. We'll reset the DSP transmit filter to 124. We'll go to transmit and watch as I cycle through the filter sizes. See here, we got to get the tone going, 50 hertz. Okay, you'll notice, quick here, I'll zoom in on the display. So you see here on 1855, the transmit filter cutoff is at 60 hertz. We're transmitting a test tone at 50 hertz. And look at this artifact going into the upper sideband. Now watch what happens as I cycle through the transmit filters. 1024, 2048, not much better, still there. Now watch what happens when I go to 4096. Wow. The filters have completely filtered out the 50 hertz tone, no artifacts on the upper sideband. Now, as I increase the filter size, we don't notice much difference, but what we do notice in the transmit filters at these high filter sizes when transmitting in sideband, you do get that tink-tink effect. It's very dramatic at 8192. It's not very noticeable at 4096, so therefore my conclusion is I'm going to run my transmit filters at 4096, and I might as well set the receive filters there as well. And you can see that that presents the cleanest spectral quality of the signal. That 50 hertz tone No artifacts into the upper sideband at the 4096. I hope you enjoyed this video. It was fun to make and very, very enlightening.